And welcome everyone to our AirMiners event. I'm Jason Grillo with AirMiners. It's good to see you all here today for our event on distributed decentralized direct air capture, distributed decentralized DAC. And so we are distributing this to you, hey, as a result of our own community who we polled a little while ago. And what bubbled up in that was a thought that people wanted to hear a little bit more about what distributed decentralized DAC is, how it works, how it operates, and what some of the opportunities and challenges lie ahead for that particular type of direct air capture. To that end, we have Mr. Jason Hochman of the Direct Air Capture Coalition, as well as an esteemed panel of startups who are working on that type of solution in the decentralized direct air capture space. A couple of housekeeping notes before we get started. One, thank you to all who contributed to making today's event a carbon negative event. Your voluntary donations or voluntary contributions are very much appreciated, for one. Two, our run of the show is going to be, as we typically do, have a conversation until maybe 45 minutes in, followed by Q&A. So feel free to ask questions in the Zoom chat. I'll monitor that and pass it along to the Jason and the panel at about 40 or 45 minutes so we can start in on that. I'll come on at the very end and then stop everything at 60 minutes in at the top of the hour again. And at that point, you're free to leave if you wish, but we'd love for you to stay so that we can do some post-event networking in Zoom breakout rooms as a way of getting to know each other, not just know of each other. That makes sense. So with that, I am going to pass the mic over to Jason.
Thank you, Jason. Thank you for that kind introduction, and thank you to all of our great panelists and to all of you for tuning into this discussion. My name is Jason Hochman. I am the co-founder and senior director of the Direct Air Capture Coalition, a nonprofit multi-stakeholder coalition organization with the goal of helping advance and accelerate the deployment of direct air capture technology to help address climate change. Direct air capture technology is often thought of as large standalone industrial facilities in far-flung remote locations. In reality, direct air capture really refers to an emerging suite of different engineered methods for removing carbon dioxide from the atmosphere. These approaches use different techniques of separating CO2 from the air and can be applied on a range of different scales and with different applications. Today, we are going to be talking to 3 leading innovators in the field about different models for distributed, decentralized direct air capture. And from there, I'm going to introduce our panelists, and I'm going to start with Eric Dahlberg of AirCella. So please go ahead, Eric.
Thank you, Jason. And hi, Jason. Hi, Jason. And I'm sorry to have to correct you right off the bat, but it's Dahlgren, not Dahlberg. Common misconception, but let's put the record straight. Eric Dahlgren, very happy to be here. I am the CEO and co-founder of AirCella. We are developing a small-scale DAC to fuels system, and the underlying ideas of this came about when I was one of Klaus Lochner's, a name that probably many of you here know, when I was one of his students about 10 years ago. So the company started more recent than that, but that's where the underpinnings of what we're trying to do comes from. Very happy to be here.
Thank you, Eric Dahlgren. Apologies. I'm going to hand it over to Joe Norris of Carbon Reform.
Hey, everyone, and thank you to both Jasons. I'm Joe Norris. I'm co-founder and CEO of Carbon Reform. At Carbon Reform, we're focused on modular direct air capture from indoor air. So we retrofit into HVAC systems. We also do comprehensive indoor air quality control. So we take care of other indoor pollutants beyond just CO2, but a part of that service is CO2 capture and permanent conversion into a carbonate.
Thank you, Joe. And Renee Haas of Neocarbon, please.
Yeah, thanks, Jason. I'm Rene, co-founder of NeoCarbon. We retrofit industrial cooling towers to perform direct air capture. We mainly leverage the airflow we get from them, but also the waste heat, which we have quite often in industries. And yeah, we are based in Berlin, just finishing our first pilot iteration to capture the first tons already. And yeah, looking forward to this session.
Great, thank you all for those introductions. The first question I'd like to pose to each of you is to just tell the audience about what are your respective business models, who are your intended customers for the services that you that your companies will be providing. And any of you feel free to jump in.
Oh, I don't mind going first. I didn't mention this as explicitly in my introduction here. I did say that we're DAC to fuels. So the input side, we can take any ambient air. And on the output side, we're starting by making methanol, and then we aim to upgrade that methanol into motor grade gasoline. So our intended big picture customer is every driver of a gasoline powered car. That's in our medium to long-term focus.
So then maybe I just continue for like retrofitting cooling towers. We go for 2 stages. In the first stage, we have identified industries that have an airflow and the waste heat we need, but also have a need for CO2. So going with utilization first. For example, first customers are potentially vertical farms, but then moving on to carbonated drinks, and in total it's a bit more than 20 industries. But this is just to learn in the field, so to go out of the lab very fast before we enter the second stage, which will be more around 2024-25, which will be our licensing model. So we are already talking to very big cooling tower manufacturers, like mainly in the US, actually, even though we are based in Europe, to license parts of our technology, and basically they run all the operations, all the service maintenance for us. And we just take care of really developing our IP and then scaling together with them, because they already have access to this huge infrastructure.
So our business model, like I mentioned, we have the indoor air quality approach to direct air capture as well. So we operate on a bit of a separate business model for the customer. Our typical customer is a commercial building owner. We're kind of working across sectors, primarily in K through 12 and higher education right now. And that way the customers can benefit from this kind of multi-dimensional value proposition, which includes decarbonization of their buildings, the indoor air quality, and then there's also an energy saving component. When we're cleaning the indoor air, they need to bring in less air from outside. And so there's an energy savings associated with less heating and cooling. So, overall energy reduction, CO2 reduction upstream and direct removal, and then the indoor air quality approach. And we operate on a leasing model currently, so we do all of the maintenance associated with the devices, so our customers don't have to worry about it.
Great. Thank you all. We're going to get into the challenges of distributed decentralized DAC, but I'd like to ask all of you first about what you see as the advantages of your respective approaches, and why you think a more distributed, decentralized approach for DAC makes sense.
Anyone? Should I go first again, Jason, or how do you want to
go for it?
Well, to me, I mentioned before that we want to make fuels for individual drivers. So the demand is already distributed, very much so distributed. And I also look at the inputs that we have, which is CO2 in the air and renewable power. Those are also very distributed. So from my perspective, it makes no sense to bunch this up and centralize it, or build a big device that makes this. But instead, if you are small, you have the ability to distribute to where it's actually needed. And by the way, I saw there were some questions coming up here. I want to make sure that you moderate them, you and Jason, so no one feels that we're not answering the questions that come up, because it was a good one. So I just want to make note that I noticed it, but I'm relying on you, Jason, and Jason to make sure that nothing is lost.
Sure, feel free to answer that if you want to take it right now.
There was someone saying that, well, if you're making fuels, won't that just go back and you're not contributing to the carbon reduction? I think that was I'm paraphrasing slightly. We view what we do is avoiding digging up fossil carbon. We don't think that the carbon as an energy carrier is going to go away anytime soon. So we still want to keep all the good, nice properties of hydrocarbons and alcohols, but we don't want to dig that out of the ground and add net CO2 in the air. So what we're doing, as long as we're powering it by green energy, which we're certainly going to do, we view that as a net zero actor on the carbon footprint. That's it. That's what I wanted to answer.
So from our side, kind of similarly, the solution is distributed because the problem is distributed. So when we're looking at CO2 in buildings and especially in cities, you mentioned at the beginning that there's direct air capture that's remotely located. That's an important technology as well, but CO2 over there is not the same as CO2 over here in terms of the human health effects. So CO2 that builds up, in urban environments, for example, can cause a feedback and be an increaser of other pollutants that are in the air, both outdoors and indoors. And then I mentioned also we have the energy savings component. So when we do CO2 capture in this indoor environment, we can actually 3x the benefit of the overall carbon removal because of the energy savings. So we're utilizing the existing infrastructure. We don't have to build a huge plant. And then we have all of these other benefits as well, kind of associated with exactly where we are doing the CO2 capture.
Yeah, for us, it's very, very similar. I would say like piggybacking on existing infrastructure has clear advantage. Like, for example, we have a CapEx save on not building our own fan, which you probably know from all the centralized approaches, but also the fan is already running. So we also have an OPEX save on the energy of just the desorption, absorption. And on the desorption side, we have an advantage on the waste heat we leverage for that, which is there just for most industry locations. So we have already 3 advantages there, and especially with our early go-to-market, we have kind of the advantage to not think about further like logistics sequestration in the early days, just to get our capturing part running before we enter the second phase of our operations.
Thank you all. And I think a big question that a lot of people have with DAC generally, and I think particularly for decentralized distributed DAC, is really the logistical question of what do you do with the carbon dioxide that you have captured. For large scale facilities, if you site it over the proper geological formation, you can mineralize it or inject it into saline aquifers, so on. How are you all, or really this question is more for Joe and Renee, Eric, DAC to fuels answers its own question, but how are you thinking about what do you do with the carbon dioxide once you've captured it? What are the logistical challenges and how are you addressing them?
Yep. So we are really focusing on building and leveraging partnerships for that purpose. Logistics, especially as an early stage company, are one of the most difficult things to even visualize. So what we're doing is, leveraging large corporate partners that are already, on the ground in billions of square feet of commercial real estate space that are interested in our technology, can help us with the maintenance. Speaking with logistics companies who are really familiar with moving around large quantities of material. And then on the startup side of things as well, looking at, okay, how can we build an entire supply chain of carbon or alkaline materials or, whatever else we might need? Who needs what we're producing? This is, I think, one of the questions in the chat, but we use a carbon neutral lime input and we sequester the CO2 into a limestone. So that can be used downstream for construction materials as an aggregate in concrete, for example. But we've also explored the option of cycling those materials with a company that's producing carbon neutral lime and a company that's doing underground sequestration or something similar. So we're not doing it all by ourselves. We're essentially mining the CO2 out of the air in our chosen environment, and then we are working with others to make sure that that CO2 isn't re-released, because we are trying to be a carbon negative solution. And I think that that's been really helpful, just to kind of try to visualize the beginning to end of the problem.
Yeah. So for us, it's also like we will not handle the logistics ourselves. So we really focus on like getting the CO2 out of the air, but we will not manage the logistics and sequestration by ourselves. So that's why in the early days we kind of skip that step by utilizing it, even though that's not completely carbon negative. Of course, it gives us certain like other advantages, like learning already from the field. And then on the later stage, we assume that the infrastructure will be ready, which is not there yet. Like you all know, the US decided to invest 3.5 billion in 4 big carbon hubs. Similar things are going in Europe. And those hubs are normally in very industrial regions, so exactly where we have our cooling towers. So basically, we can piggyback on those which are close to those hubs, where we can also have this infrastructure ready. And before we learn from the utilization phase, which we are now entering.
Thank you. Kind of piggybacking on that question, I'd like to ask about, starting with Renee, about kind of the policies that you're seeing in the EU, how they're different than what you're seeing in the United States, and for everyone, how the policy atmosphere or how the policy framework is evolving, and what you would like to see coming from the local, state, national, international level to help advance your solutions.
So in general, I think Europe is moving slower than the US. So I think there has some big breakthrough happening right now in the US. Of course, what was an advantage? We had first this ETS trading system, so this first really carbon market system in the US, in Europe. So this was something where we have been kind of ahead. But at the moment, I'm looking forward to like really stronger regulations of like clear definitions, what is like different standards, which we basically need for technical removal solutions, that they are kind of in different categories, because at a certain point we will not come along without them. So there is this like clear framework, a clear incentive structure, which you're now developing in the US. This is really missing here in Europe, I would say, at the moment. But of course, Europe is looking to the US, so it's a good step forward for the US, and that's with this also in Europe, I hope.
Joe or
Yeah.
Eric, feel free to jump in. Do you have any thoughts on the policy environment?
Yeah, I mean, we kind of operate in a different policy environment because we have buildings to contend with. So the good thing is that we have seen that the powers that be, at least in the US, in reference to commercial buildings, so ASHRAE is the big one, they are aware of both sides of what we're going after, which is really the decarbonization and indoor air quality. Everyone has been made much more aware of indoor air quality since COVID. And they are also examining indoor CO2 levels and what the changing outdoor CO2 means for that. So we're kind of waiting to see. We're engaging as much as we can. We're presenting at a couple of different ASHRAE conferences coming up, and really just trying to scope out what that landscape is going to look like. These trade organizations and regulatory bodies move notoriously slowly. So we are trying to propel them as much as possible, but also just engaging, at a state and local level, more directly with kind of local policymakers to say, hey, here's what we have. Here's the funding that we think that we can get out of like the IRA, for example, and let's work together to actually try to take most advantage of what's out there already.
On our end at Aircella, I don't think I know that we're in a position that we are less sensitive to the policies out there. So to a first order approximation for us, I'm somewhat agnostic, but I would like to see policies that can make the entire direct air capture space succeed. So anything that would work for Joe and Renee, who does other products, and if that supports them, I'm all for it. So that's our first order approximation. Now, if we dig a little bit deeper into it, I would like to see that e-fuels that are generated with a net zero footprint come in and is folded into various pieces of legislation that are coming out demanding net zero transportation. That's what I would like to see. But I think the time horizon there is so long that we're not holding our breaths for any policy to come to place for us to do what we think that we need to do.
Got it. All makes sense. And kind of touching on the idea of a long time horizon, let's fast forward to the year 2030. What do you all see as an ambitious target for how much carbon dioxide your respective companies would be able to be capturing, removing, or converting into fuel? What kind of scale are we talking about from, if we were able to scale this more distributed, decentralized approach?
I don't mind going first there. Currently in the US, a bit more than 100 billion gallons of gasoline is sold every year. If we are not in the range of hundreds of megatons per year, if not even sniffing the gigaton limit, we have not succeeded. I know this is a very, very ambitious goal, but that's where we're coming from. So that's where we set our ambition by 2030.
Yeah, I mean, yeah. So I was just pulling up our like projections. I mean, we have, again, like a lot of assumptions are baked into these models. We have what we would hope for, you know, at least by 2030, cumulatively getting to like the megaton scale, especially because we have the kind of combination of the direct capture and the avoided from energy savings. But that all depends on, you know, market scaling as well. So again, you know, trying to really leverage existing partnerships, manufacturing partnerships. We operate on a clustered market approach. So when we are expanding, we have a certain radius where we can transport material, assuming, you know, we're using trucking that we're not capturing the CO2 of. So it's a complicated question, and I'm sure we've all thought a lot about it. And we have, you know, the vision that we tell investors and the vision that we tell customers, and ultimately it really is going to depend on people buying into that vision, right? So yeah, anyway, long story short, we're looking at megaton scale by 2030.
Yeah. So for us, we are more looking on the like hundreds of thousands of tons, like roughly 300,000 tons annually by 2030. But like Joe mentioned, it depends a lot on basically everything, like who are our industry players. But there on the good end, we get quite a lot of demand from even big players that really want to support us with early pilots, with R&D support. So we are quite optimistic there. But of course, like I said, it really depends on the regulations, how fast they move. And then it's still a lot about science and a lot of like really physical and chemical problems. And of course, you can throw money on them, but still it needs time to solve them. And yeah, only time will tell if we can really achieve that. But without achieving that, of course, we face some quite big issues. So yeah, we're hoping for the 100,000 of tons by 2030.
All very exciting and ambitious aspirations we're hearing from panelists and their companies. I wanted to ask, so there are over 100 folks tuned in watching this. Afterward, Jason will put it up on the AirMiners YouTube channel. Who do you hope is watching this right now, and what message would you want to try to get across from them, or to have them take away? and anyone can feel free to.
Oh, I don't mind
in.
starting, and I want to append my previous statement by saying one of the restrictions or constrictions that we see in order to reach that very ambitious scale is the availability of renewable power. That is an off-grid generation discussion that I would love to get into. I wouldn't be that ambitious if I think that all that power has to go through the grid. That would be difficult. So instead, we see that off-grid generation is the key to unlocking vast amounts of primary renewable energy. So that's what we're sort of piggybacking on and hoping we can achieve with those scales. If there's anything that the audience to hear here, I would say that first, I think direct air capture is a very interesting field. You see the three of us are doing three different things. I think there's going to be plenty more companies out there, and I think there's room for everyone to succeed. After all, there is 40 gigatons annually that is being emitted. So there's plenty of supply for us to do interesting things with. And it's only your imagination that stops you there, I think. So I hope everyone takes away that there's plenty of opportunities out there.
Yeah, I mean, I think in terms of who I hope is watching this or would get access to this, I guess have a less inspirational message. I would hope that there are like lobbyists who can help us out a bit more. Like, you know, we've seen like policy change, 45Q, we need some clarity on that. Like, you know, as we've said, there are many different ways to go about solving this problem, and there are many subcategories of problems, and we as innovators don't really have the time to be the ones that are talking to the policy people constantly and saying like, and trying to keep them up with whatever is going on in the space. So I think that, you know, if people have are close with policy or are policymakers themselves, trying to get involved in groups like this and keep up to date with what is going on at any given time, because it's changing, you know, by the day, which is exciting. You know, it's fun to be a part of. But I think that's who I would hope is listening to this and seeing that we need some help.
So yeah, for Neocarbon individually, it's a bit different. Of course, there are a lot of things that we have in mind, but for us right now, core is to find great talent. So we just finished our next product iteration, and now we want to scale our team. So really looking for engineers, chemical engineers, chemists, but also mechanical engineers to join the team very soon. Like, this is our biggest ask at the moment. So if you know someone who's interested, who's in Europe, we are very open to talk. It's in general, I think it's a very international company. So we have I think we have more nationalities than people by now. So quite a cool work environment, I hope. So that's my biggest ask and my biggest challenge at the moment, even though we have great applicants already. Like, we're really happy with the demand and the smart people that work on this challenge. But of course, we want to create a great team or like develop this even further. So like, whoever you know, please feel free to just send them my contacts, and happy to chat.
You heard that, anyone who's listening, looking for a job in the carbon removal space, reach out to Renee.
Yeah, we are too. Just saying, we're hiring.
And Joe. So we talked briefly about kind of the longer term vision about where you would see yourselves in 2030. Looking at it more in the immediate or near term, what are the next steps for each of your respective companies in terms of deploying your technology, in terms of actually using your technology to get carbon dioxide out of the atmosphere? So any of you, please feel free to jump in on sharing your deployment timeline.
Yeah, I can start that. So we are working on, so we spent the last few years doing some kind of internal R&D. We've gotten lab scale prototypes up and running, and we are installing our first full scale pilot unit by the end of this year. And then kind of following that, we're planning to do a couple more pilots and roll out initial commercial efforts by end of next year or so. So, you know, looking at, I mean, immediately starting to capture CO2 once the pilots are up and running. But we'll be, you know, within several years being like actually carbon negative because we need to build out manufacturing.
I can pick up this thread. So Aircella is right now somewhere in between proof of concept and prototype stage. We'll finish that by the end of the year, and then we will pilot our system sometime next year. That will be a DAC to most likely methanol. And just like Joe, after we've done the piloting, then it's all about getting into production to really ramp up capacity. And I hope that that will happen sometime in the late 2023, 2024 timeframe.
Yeah, so for us, like mentioned, we are in the lab scale at the moment, but we want to bring this lab scale MVP in the real world later this year. So we have the first potential pilot customers around Berlin, so in Germany, but also across the border, like in some other countries as well. But of course, keeping it close makes sense in the early days. And then going for a commercial pilot, which is more in the hundreds of tons next year. So early, mid next year, depends, of course, a bit how the hiring goes, how fast we can scale the team and all of that.
All sounds very exciting, and I think everyone on here will be rooting you all on to achieve those timelines. I wanted to also ask, what are the biggest perceptual challenges that you're finding in this space, or the misconceptions or misperceptions that you think need to be cleared up? Or does everyone kind of get it that you're talking to?
Well, from whose perspective, I guess is my follow-up question.
From policymakers, investors, general public, perhaps environmental advocacy groups, whoever you're seeing that could use more education or awareness raising on what you're doing.
Yeah, I mean, I think from investors, we're getting into, the HVAC space. And I think during like the energy efficiency push, some investors didn't make good investments and have been burned. And so now they're looking at us as an energy efficiency technology, which is not what we are. We're an energy reduction technology, if anything. But so that's been a misconception that we didn't really expect to have to deal with, and we are. We're still having a good amount of success with investors, but then on the other side, climate focused investors are still trying to figure out decentralized or distributed carbon removal. So that's also something where they're like, well, how are you going to scale it? And this is a huge logistic undertaking. And we're like, no, we know. Here are the ways that we're going to do it. But yeah, so it's kind of this strange limbo space that we've been dealing with.
So maybe to jump in, from our end, like perceptual issues, there's not really a thing. I would say. I think what a lot of people don't understand when I talk about cooling towers, if that we are not talking about exhaust streams. So it's still direct air capture. It's just that they move a lot of air, but it's still 400 ppm. So this is, but I would not have a group that gets this wrong. Like, it's actually a lot of people that get this wrong and don't understand that we still use ambient air and not higher concentrations. But it's more a general issue, probably because people are not aware of how a cooling tower functions. But that's, yeah, more a general thing. But in general, what I realized, a lot of people are very open for the technology, and a lot of people realize from industries, but also investors, also potential pilot partners, that we definitely have to remove carbon from the atmosphere. So this is something like I think where most of the people align that we talk to, like basically from all stakeholders.
Yep. Oh, go ahead.
No, look, we touched upon this in the discussion before. Someone asked, well, if you're making fuels, isn't that going back out again? So if you're making liquid fuels from DAC carbon, what kind of impact does that have on climate? And I think for us, it will be our challenge to make sure that people understand that a gallon used of our fuel is a gallon avoided to being dug up out of the ground. That in and of itself gives us a runway to, I think, get to carbon reduction sooner, net emissions sooner, I should say, than with the other means of doing this. But there's some discussions to be had. I wouldn't necessarily call it education, because that could be maybe a bit patronizing, but I'm looking forward. If anyone wants to discuss this, I'm here, and I hope we can have one lively discussion.
Yeah, I think that getting the knowledge out there may be a better way to phrase it. I think that one real open question that exists throughout this space and throughout carbon removal is about cost and getting down the cost curve. So without, you can answer this, in terms of your particular technology or just the field more broadly, where do you see the greatest potential for realizing innovations in terms of reducing costs, increasing effectiveness? Where do you see the greatest levers there for getting the cost down for carbon dioxide removal per ton?
I think this is something that the three of us are all aware of. One of the biggest costs and sources of like energy need for DAC is moving air, and there's already a lot of moving air. So that's kind of how we're looking at existing infrastructure as a cost savings. And that goes for the energy required to run the systems, the energy required to build the capability of, installing these systems, but then just also not having to source new materials and really taking advantage of what is already there and thinking creatively about the different ways that we can do this. And no one solution is going to solve it, and no one solution is going to be perfect, but we're trying, right? And that is something that I think is really important to realize in terms of costs. Like, we have to do some weird stuff sometimes, but for us, it's been successful so far, and we're looking forward to gaining more support on that.
So yeah, for us, it's of course energy, like that's a huge thing. So first of all, of course, green energy is what we need, but also using energy which is already out there, like already air that is being moved, but also, like in our case, especially waste heat, which is just there, which we can utilize. Like, I think these are the first steps to get our costs down. In the long run, of course, we also think about certain sorbents, like our capture material. So we have different kind of research tracks with quite some big corporates together to create new shapes for our sorbent, which have different advantages, basically to extend the lifetime and the efficiency of the sorbent, which will be a long-term success then to get the next step down, like first the energy and then the sorbent. That's how I see it.
And I would like to round this out with, for us, it's actually two things that will get us down the cost curve. One is the fact that being small and being distributed and decentralized means that you can get access to energy that is already decentralized and on that small scale. That means that you can be off-grid. And the moment you're off-grid, you can now rely on photovoltaic power, for instance, in a much cheaper form than you would had you go through the grid. So off-grid power for us is the main main lever to pull in order to get free, or not free, I wish, but cheaper electricity. The other thing that when you're small scale, you can rely on or should rely on is the notion that you can actually mass produce your components. I would be looking at the photovoltaic panel that the early iterations of that back in the 60s and 70s, I believe, they were around $100 a watt peak. And now they're at 20, 30 cents a watt peak. And that is because they've gone through many generations of production. And as you come down that learning curve, in order to come down that learning curve, you need to produce a whole lot of them. So cost reductions through mass production. That's our approach.
Thank you. My last question before we turn it over to Q&A is, what advice would you have to those in the audience who want to found and grow their own distributed decentralized DAC company?
Okay, then maybe I go first. Maybe I can just, of course, share my experience. I worked in a startup before that was, I would say, quite successful. So we raised quite a lot of amount, and the team I was leading was quite big. And I learned a lot from that. And I think it's very helpful if you want to support the industry, just to like spend a year or two with already a founder, like that's meaning being close to a founder. Like that's basically what I did. So I was an entrepreneur in residence and then became the head of business development. And I learned a lot just by following like his guidance and how to manage people, because it's a lot about science, of course, but also building a company is a lot about people management and how to scale, setting the right structures, being fair to everyone, being transparent, but also like there are a lot of things in mind besides just being an expert in direct air capture. It's a lot about how to build a company. And I would really recommend learning this in a very early stage startup. So you can like get the right learning for you, so you can really define how your startup should look like. Yeah, that's my 2 cents.
Joe or Eric, any words of wisdom?
That would have been great advice for me to hear before I tried doing this, because I didn't. Yeah, so for me, it was basically, there is no perfect time to just go ahead and do it. I also highly recommend having a co-founder, or at least like a very trusted advisor to help you, because you'll realize really quickly, especially if you are like either the business lead or the technical lead, that you run out of space and time so fast. And that's a good problem to have, because it means that, you know, people are believing in your idea. And then the other thing that I would say, you know, especially, I can only speak to my own experience as a woman in tech. Get used to people telling you that it's not going to work. Get used to people telling you that it's a bad idea, and like listen to them if they know what they're talking about. You know, definitely do your research, do some customer discovery really early on, like when you have no idea if this is even the idea you're going with. But then once you feel like you actually know enough, stick to it and see what happens, because it might work, and that's all you can hope for.
Yeah, just to add there, I totally agree with Joe. Like, really listen to all the people that give you a lot of like shit. I would say some of their advice is really helpful. Of course, you still have to believe in your idea, and having the right co-founder, like someone you really trust blindly, is super valuable, because there are so many ups and downs. Like really having the right co-founder for you personally, and this is something you have to decide on your own. That's definitely core to the business, and without that, it's like impossible, I would say. There are some people that are super successful solo founders, but that's so hard. So really having the right co-founder team, and even having some more people, like we are just 2, but 3 or 4 would be no problem. Like there's so much work you have to do at the beginning. So definitely go for the right team.
I have nothing smarter than Joe said here to add. Those were so on point that close this out, Jason. She said it.
I'll hand it over to Jason G.
All right. Awesome. Excellent insights from all of you. And thank you, Jason, for a great job of moderating the discussion. What we want to do now is turn a little bit to audience Q&A. And Avery, you had a question earlier. Avery Carmichael, feel free to unmute yourself and ask a question of the panel.
Yeah, thanks, Jason. Avery Carmichael, I'm a consultant at Wood Mackenzie. So I was just curious, it sounds like as early movers, everyone was comfortable moving forward without great policy support. You obviously had other, plans, I guess. With the new legislation in the US, any early thoughts on how that could change kind of funding in the space? Does that mean that the huge DAC projects are now more palatable? Are industry partners more willing to come to you guys because they might see a bigger benefit? Just curious if there are any early, I know it's early days, but any thoughts on that? Thank you.
Yeah, I mean, it's fantastic, right? Like it's something finally. And for us, we've really been focused, just based on how our business model works. We've been focused on getting funding, like project funding for our customers to be able to use it to install our technology. So we operate on the like kind of leasing model. It's an annual fee, but we have that initial like upfront cost of retrofit, which is kind of unavoidable, just because we're working with existing systems. They all look different. So that's really the biggest. Some of our customers, don't have a problem with it, but especially in the educational sector. So we're really looking to like take advantage of the new legislation and funding for that purpose specifically. And like I said, we're kind of still waiting to see and to get some clarity around like, what does that look like? How do you even access it? And so on.
Okay, cool. Anything else from anyone else? Or nope. Okay. Sir, Renee, go ahead.
Yeah, so maybe just to add there, of course, it will get even more demand, but especially on our end, we already had quite a high investor demand. So even before this decision, I think investors have been aware of it, and now it will just be even more, which will enable even more solutions, which we will definitely need because it's such a huge issue. But yeah, so that's just my 2 cents. Jason, you can continue.
Yeah, thank you guys.
Okay, Madison, you had a question about, actually several questions. Madison Dunitz.
Hi, yeah. So I'm just wondering kind of what you guys are all doing to support the larger air capture community. Are you making sort of the technology you use available for other people to build upon? As you guys stated, this is sort of an all hands on deck problem. And there's a lot, I suspect, that you've developed that other people could really benefit from.
Oh, can I jump in on this, Jason? I think one of the things that we're trying to do that comes sort of inevitably with a small and distributed scale is that you're moving air capture technology implementation closer to the end user. So you raise public awareness that carbon is actually something that can be done, handled, and you can do valuable things with that carbon. I think the more direct air capture we put almost literally in the hands of the public, that raises awareness for it, and that makes it easier to accept projects that might be a bit more out of sight, out of mind to most people. But I think there's a big educational gap that we, the entire community, needs to do to convince the general population that direct air capture is incredibly useful and also valuable and necessary for us if we want to meet the climate goals that we all have. And visibility is how we want to get there.
Yeah, agreed. I mean, to the extent of like sharing IP or making things available, I know that that's something that like certain, like the Open Air Collective does. So I think that that's important. You know, we all, I'm sure, do a lot of time sharing. We're not getting paid for this right now, just so you know, which is totally fine. But I think like participating in public dialogue about this is equally important. You know, we also tend to, like I said, make partnerships with the other types of companies that are up and coming, where, you know, we're sharing knowledge on it, but we're also trying to close the gaps in those supply chains. Because I mean, I think there's some use in like everyone having a carbon capture machine at their house, but how are they getting those materials, right? If you're ordering stuff off Amazon, there's a whole carbon like footprint associated with that as well. So like what we do is like full life cycle analysis and try to get somewhere close to Pareto optimality when it comes to developing this technology. So, you know, I think that there's some happy medium there in terms of engaging the public and trying to educate about what it is that we're doing, but not necessarily making it so that we can't be successful because all our IP is just public information.
I'm going to just jump in here quickly. All three of the panelists and their companies are part of, I'm going to make a plug for my own organization, the Direct Air Capture Coalition, which I think is a testament to the fact that nearly every company in this space and interested stakeholder understands that there is a real need for collaboration and cooperation within reason among the different technology companies, their supply chain, value chain partners, the nonprofit entities interested in this space, and the research and academic institutions that are trying to foster and create knowledge and share knowledge in the direct air capture world. So I think that the whole is greater than the sum of its parts in a lot of ways, and there's a lot of desire to see this field advance, and that there is room for there to be a whole lot of winners in all senses. And everyone is really, and just coming from conversations that I've had with the three individuals on this panel and others, everyone wants to see this space succeed and are open to finding ways and eager to find ways to advance the ball. It's an unfortunate, metaphor in the world of climate change and sea level rise, but a rising tide will lift all boats in the direct air capture space.
Yeah, very much underscores our culture here in AirMiners in general as well. So thank you for that, Jason. We'll have time for Wenru and then Greg for questions, and then I'm not sure if we'll have time for anyone else. But Wenru, quickly, if you don't mind asking a question about carbon credits.
Yes. So this is Wenru. So I browsed the website of some of you. I think Carbon Reform and also Neo Carbon all like put the carbon credits as one of the products. So do you think, or is it already like the current status, are like those carbon offsets or like carbon credits one of your main products, or do you think they will be in the future, especially due to the decentralization, trade or characteristic? And also another short question is like for cooling towers or commercial buildings, are those carbon credits or offsets directly went to the operators themselves or the building owners? Just confused about that. Thank you.
Yeah, so I can't talk about the cooling towers, but for us, the carbon credits come from essentially allowing our customers to generate carbon credits on site. So we have the direct capture and the energy savings, and those are different pricing per credit for the different types of offset or avoidance. So what we are doing because of that kind of complication, we have a lot of monitoring that goes into our system. So we have sensors, the directly captured carbon we can literally weigh, and then the energy offsets, we have access to like the energy usage for the building. So we are taking care of setting our customers up on the platform for the verification and the sale of those carbon credits, and then we will just have like a sharing model with them. So currently we are still vetting like different platforms for doing that, because that's also a developing market, and so we're trying to make sure that we aren't putting all our eggs in one basket or buying into something that's currently still a startup that's not going to last. So trying to still, keep an eye on that development.
So yeah, on our end regarding the carbon removal credits, we have not sold carbon removal credits yet, but we just had today our first call for selling to potential, like 5 big corporates have been invited for that. So that's definitely an option for us, especially like future carbon credits, which we can deliver some years later, which also fits our timeline. So that's definitely something we're working on. Regarding the cooling tower owners, we are quite flexible with that, because that's also part of a bit later stage. So now we are having the first MOUs from those big cooling tower manufacturers are incoming, and that really depends on the setup. Like, we personally have already contact to quite some marketplaces, but if they at the end want to have it for themselves, the carbon credit, then we have nothing against that. So we are still quite open for that, and more like, okay, what is the approach that can help accelerate our technology and can remove more carbon from the atmosphere? And if it's at the end us or the cooling tower manufacturer or the cooling tower owner who gets the credit, and then how the split will be, that's not something that is core. It is more something that we have to figure out with the overall goal of maximizing carbon removal overall.
Thank you. That's very interesting.
Great.
Yeah.
Dr. Greg Rao, real quick, just maybe ask you a question, then maybe I know it's a very complicated subject that you want to dive into, but feel free to ask, and then we'll see how far we can get, maybe in a minute or so.
Okay, thanks. Yeah, can you hear me?
Yes.
Yeah, thanks guys for the overview. Yeah, every time I attend a DAC meeting, I ask myself this question: what qualifies as direct air capture? And I ask that because there seems to be lots of ways of directly capturing CO2 from air. For example, a tree, a pile of finely ground ultramafic rocks, adding alkalinity to the ocean, etc. Yet, as far as I know, none of those are, have enjoyed the policy incentives and inclusion that making concentrated CO2 from air has enjoyed. So I guess my question is, do you have plans to broaden the definition of air capture to include a variety of other examples of that, or is this going to remain exclusively as a process that must concentrate CO2 from air and then do something with it? Thank you.
Big question. Maybe if we could go quickly, because we are almost at the top of the hour.
I can jump in on that. I think that the broader host of methods that remove carbon dioxide from the air, fall under the broader portfolio of carbon dioxide removal. You have the nature-based approaches, you have biochar, you have ocean-based methods. When I think of direct air capture, I think of technological, engineered-based methods of removing carbon dioxide from the ambient air. And so obviously a tree, or ocean-based ocean alkalinity enhancement wouldn't necessarily qualify into that. But I do think that aligning on agreed upon taxonomies and nomenclature and definitions is important in many regards. And I'm sorry if that doesn't really answer the question, but I do think it is important, though, to understand that there are a variety of methods of carbon dioxide removal, and within that broader portfolio, there are different engineered solutions that I think are commonly referred to that use chemical or electrochemical or geochemical processes that are commonly referred to as direct air capture or DAC.
Got it. And with that, thank you, Jason, and thank you, Greg, and thank you everyone, to our audience, to our panel, to Jason, our moderator, for an excellent event. We are glad you came and hope to see you at a new AirMiners event in the future. Next week, actually in 2 weeks' time, we are going to have an event unpacking the Inflation Reduction Act. across all methods of carbon removal. And looking forward to that. Keep your eyes posted for an announcement coming shortly. And please answer our post-event survey. You'll be getting an email as well. However, we'd love to hear your feedback on new and interesting things that we can do to make our events even better for you.